Right, welcome. I think it's time to start now. Maybe it was a bit short, but the next talk will be by Vazen on making simple musical interfaces and instruments. And for those who really liked it, there's going to be a workshop tomorrow at 11. Should you already be up and running at the Congress Center.
Get some coffee and join the workshop tomorrow with some cup of coffee. I've got hardware as well. So.
All right, sounds great. Get loads of coffee. Enjoy.
Hey, thanks. Hello, I'm Vazen, or Manuel, and I'm going to talk about making music and especially programming musical algorithms on special hardware. So I've brought some development boards with me. We're going to be able to use them to show you some stuff. So I'll first start with some kind of intro. If I just, I'm going to talk about algorithmic music mostly. And I've been producing electronic music for the last 3 years probably. I started with just doing some kind of beats on the computer and then moved on to doing mostly music with hardware. I'm playing bass as well, so I'm like kind of touching everything a bit. But my real background is actually in programming and hacking. I've been going to Congress for 10 years and learned electronics on the fly during just a few years, especially because I was interested in building MIDI controllers using microcontrollers. So I think this is a picture of the first controller I built about 3 years ago, which was this really big, clunky box, wooden box, with some potentiometers, some knobs you can turn and then some buttons you can press. And it actually worked quite nice, and I did a few gigs with it, and then it broke, and every week there was like one part that was broken. But the actual insides of the box are pretty much the same than what I'm using now. This one had, who knows about MIDI, about microcontrollers? Sorry, just like, okay. So, and who knows about MIDI and synthesizers? Okay, quite a few more. So, basically a microcontroller is just a small CPU in a chip that often has a lot of input-output hardware, so you can just hook up switches to it and pods. And that's what I've been using in this box, for example. There's one controller which polls the whole devices, like ask which value has this pod and is the button pressed, and a second Atmel doing USB, which is slightly more complicated, but it's one of the main things which led me on to build all this stuff. So that was 3 years ago. I did like 2 gigs with it, then noticed it was way too clunky, way too prone to errors and trouble, but it was actually really nice to be able to just program the stuff I was thinking of. And if you buy a finished MIDI controller, you basically have some kind of software to edit it, but once you hit the limitations, you're just stuck and you can't really do what you want with it. So that was the thing I really appreciated about building this device, is just being able to put in the stuff I really needed and have it the way I wanted it to be. From there on, I moved to using the computer for music production, to using special synthesizers and hardware about 1 year ago. And that changed my whole way to do music, actually. On the computer, you can just like pull in some big programs and program some complicated stuff that's going to generate music in some kind of weird ways, but in the end, it doesn't sound really good most of the time. And I've been moving on to mostly this synthesizer I have here, which is just a drum machine, so you can just have sounds like this, make some kind of music out of it. And in the process of doing that, I've been focusing on a lot of more minimal ideas. You just have like 2 bars to make music on this one, and you don't have all the options of doing the stuff on a computer. But since all these ideas are pretty simple, the whole physical feedback takes a much more significant aspect of making music, like being able to turn knobs and explore stuff away from the computer, away from the internet and from chat programs. And it really changed the way I did music, and that's the first few tracks I really liked came out of this. But it also has its limitations. Most of the limitations are you can store 2 megabytes of samples on this one and like 4 gigabytes in RAM on this one. And if there's a feature you want to access and you can't really access it easily, there's no way to get out of it. So for example, on this machine I have an effect called a delay, which just repeats sounds at specific intervals. And to access the parameters for this delay, you have to enter menus and press a lot of buttons. So it's not really something you would like to use live and change the settings on the delay when you're in a club. So, I downloaded the manual for this machine, and when I'm looking for manufacturer-specific messages to change the way the delay is set, and found out that you can actually set the delay settings using a MIDI message which is sent over this cable. And while doing that, I decided to build a new MIDI controller which just had 4 parts and MIDI out just to control the delay. And I did this, and it again completely changed the way I did music, just being able to access some parts of the instrument and turn it into a real new instrument I'm actually really comfortable with playing now. I practiced a lot, and now I like to, I don't know if you listened at the beginning where I was playing a lot with the delay while I was playing. And that got me really excited about the way to actually, hack existing synthesizers to use features which I don't really have just by adding some hardware and then suddenly being able to change a lot more things. So I spent a lot of time then reading internals and doing some MIDI programming and programming on microcontrollers, and found a lot more new ideas to actually use, for example, this drum machine. While doing that, I decided, I noticed like a lot of people were actually interested in using that stuff as well, so I decided to create a company last year. So that's the only company slide. I did a new design of the controller, which allowed to hack around a lot of limitations of the machine drum, which is this device and another synthesizer called the Mono Machine. But I actually noticed you can actually apply that kind of thinking to every software and MIDI hardware which is out there and trying to, make it fit your needs. So, yeah, I've decided with a friend called Ruin, who does analog electronics, to start a company which is actually based around this hacking open source kind of idea. So we put all the schematics online and source code. And that's the company slide. So those are the 2 new controllers I built, which evolved from the idea of this simple controller which you can actually program yourself. And what I did is, that took me a long time to get there, but I finally decided to use the Arduino software environment, which is a software environment which allows you to really easily write programs for microcontrollers, and just like write a few lines and upload it and test it out. So you can actually, less than program an application, just write some sketches and try them out and see what it does. And I've been integrating both our controllers into this environment, and since I did that about 10 days ago, I've been writing approximately 20 new firmwares in just 1 week, because I was just like trying out nice ideas. And this is actually what I'm going to talk about in this talk. So that was the introduction to show you where I'm coming from. And we're now getting to where the fun is. And while thinking about all these things, I've been really interested in musical theory and aspects of flow. How does your environment or your instrument influence you when you're doing music? Like, for example, why did I never do some kind of minimal techno while using the computer, but started doing this when I had the hardware? And also some kind of really nice insights which came out of trying different algorithms to work with rhythm, and suddenly start to notice that actually most of African and Western music is kind of based about some core ideas which make some music funky and some other music not so funky. And it's actually numbers. It's actually, for me, it's numbers. And that's what I'm going to talk about as well, which is really what fuels all my hacking of these things. So, yeah, I think it's pretty nice to be a programmer interested in music, or musician interested in programming, because it allows you, to merge hacking ideas and like musical ideas, musical theory you have on one side, and then programming theory on the other side. For example, if you studied classical music and started writing Counterpoint, which has a lot of rules as well. You always want to kind of put a mathematical frame on it, and I started to notice that both the creative aspect and the theory aspect of it fuel each other, which is really, really interesting. So I've got some posting on my blog about the links between techno, for example, and African traditional music, which is really something, very simple when you see it, but it's kind of pervasive. So that's what interests me the most in the hacking side of it. But now let's get to some technical details. So MIDI is a pretty old protocol which is used to communicate between hardware machines or computers to exchange musical information. It was actually published in 1983, so 25 years ago. And it's based on a serial link with 30,000 bits per second, so it's really slow. And it has separate wires for receiving and sending. So for example, this is the sending side of the drum machine, and this is the other cable which receives the information, so it's really, you can really see it. There's some kind of electronic information, it's a current loop, so if you want to see the board tomorrow, so there's this chip which does the conversion. So there's a lot of thought that actually went into this protocol, and I think it's kind of interesting that even 25 years later we're still using it mostly for most of that electronic music connection, even though we have USB, and there's some new standard which is based on Ethernet mostly. But we're still using MIDI actually in the studio most of the time. So the MIDI information on the cable is encoded in bytes, but there's one slight trick that the most significant bit of that byte is used as a command flag, so you can do signaling of commands. So all these values from 0 to 127 are data bytes, and the rest is comment bytes. So it's pretty easy to check if you just received a comment or some data byte. On MIDI, you also have MIDI channels, which is another way to multiplex information on this one serial link. So you can have 16 MIDI channels on one cable, basically. So you can connect multiple synthesizers and address them individually. And the MIDI channel is always encoded in the lower nibble of the command byte. So devices can listen on a specific MIDI channel or on all channels. And there's this thing called system messages, which is further split into real-time messages and system-exclusive messages, I think they're called, which is used to actually send some kind of system information which is not musical. So those are the commands you have for music. So you can send notes on. That's, for example, when you press a key on a keyboard, it's going to send a note on, and when you release the key, it's going to send a note off. And you can use controller change messages if you turn the knob, for example. It sends just a value from 0 to 127. Then you can use program changes to, for example, change the sound on a synthesizer or to load a new track, maybe. That's kind of manufacturer-specific as well. You have weirder messages like aftertouch, which is used on touch-sensitive instruments or keyboards. So you can press the key and then continue to press it, and it will send the information. But then you have real-time commands, which are called real-time because they have a high priority. So it's clock messages, for example. If you have something which is called a sequencer, which is basically just a program that sends back stored information, it's going to have to be synchronized to, for example, another sequencer, so that they don't start to play out of phase, out of rhythm. So it sends a lot of these clock messages regularly on the MIDI cable, and it's used to synchronize sequencers, for example. You have start and stop messages, and then actually the most interesting kind of message for hacking is system exclusive, which is just, this is a bunch of bytes, do whatever you want with it. And if you remember correctly, it's 8-bit bytes, but the higher bit is used for command signaling. So if you do some sysx messaging, you have to encode the 8-bits data and 7-bits data and then put it back out the same way at the other end. So it's pretty annoying if you just want to write out something and you always have to encode stuff. Sorry?